So welcome. This is 1010 minutes with me, right? So I'm the assistant professor in the Department of Applied Computing at Michigan Tech. So in this presentation, maybe first of all, I'll introduce myself, including my educational background in US, also my kind of professional development over the years. And then I'm going to talk about my research, like topics and recent projects and so on. So you may have better understanding, on myself, also my research area. All right. So my name is Sidike Paheding. Right. So I joined Michigan Tech last fall as a assistant professor. So I'm in the Department of Applied Computing at College of Computing. Right. I'm also affiliated with the Department of Computer Science, and also I am the affiliate faculty with Center of Data Science at ICC, also the faculty at Computational Science and Engineering PhD program, right? So I did my master, right, Master of Science at the University of South Alabama, as you can see from here. I started my grad school in the very kind of bottom of the US, in the south part of the US here. And then I started to go to Midwest, right, go to the Ohio, and I did my PhD. During my PhD, I focused on the area of the computer vision, machine learning. That's my PhD study. I obtained my PhD degree in electrical engineering, but I focus on the kind of computing parts, such as computer vision and also artificial intelligence. So right after I finished my PhD, I went to St. Louis University, in the Missouri. I did a postdoc over there, where actually I applied my skills in the area of computer vision, machine learning to the remote sensing area. Right, I did a lot of image analysis. I did analysis on the satellite, also UV imagery, and we developed a kind of intelligent tool that can automate many processes in the area of geoscience and remote sensing. Then I went to Purdue University, Northwest, as a visiting assistant professor. I spent a year over there in the Department of Electrical and Computer Engineering. I did some teaching, also I continued my research. Eventually, last fall, right, I'm very pleased to join the Michigan Tech as an assistant professor, right? So I'm here right now. So this is my second semester. So from here, from this map, as you can see, I'm trying to climb up, right, from very south to US then to the north. I think I already reached the top of the US over there. So no more way to go. I think I'm going to stay here. In terms of research, here I'm just showing the kind of like 5 different areas that I've been focused on for my research. Including data acquisition, pre-processing, feature extraction, classification, regression, and decision making. Right. So data acquisition, basically, what we do actually is we use either like a regular surveillance camera or UV airborne and satellite imagery to capture multidimensional data, including like RGB color images, right? We use array-take pictures that contains 3 spectral bands that they are RGB, red, green, blue, right? And also sometimes we have more advanced sensors where we have more than 100 spectral bands, right? Or even 200 spectral bands, right? We can use those spectral bands information to detect targets and do further analysis, right? So I have done some work where we use those UV airborne or satellite imagery to detect objects, also make some decision. So once we have data, in many cases, what will happen is we cannot get really good quality, especially when it comes to the remote sensing data, right? Because we capture data remotely, and we have a lot of sensor noise or Also, sometimes we have environmental noises. In this case, what we do actually is we do pre-processing, right? From this example, as you can see, we have an image's RGB color image, and it looks very dark, right? You cannot really see clearly what's inside of this image, right? So what we do actually is we apply or develop some kind of techniques. It can enhance illumination in this image so that you can see the object clearly from the image, right? This is the enhanced image, right? So in this pre-processing step, we actually develop some kind of mathematical model, and we do kind of simulation, try to analyze each pixel imagery in the images, and then try to enhance it so that you can see the object clearly. Okay, so this pre-processing step includes like illumination enhancement, distortion correction, and also super resolution. Super resolution means, sometimes you have really low spatial resolution imagery where object is really blurred. So in that case, we want to enhance the spatial resolution so that you can see high definition imagery. Okay, that's a concept of it. So once we have pre-processing steps done, then we come to feature extraction. Feature extraction. So in this case, what happens is we have this very good quality image right now, right? And we want to detect some targets. Okay? And if we directly go to raw imagery to detect target, and the algorithm, such as machine learning algorithm, always also analyze noise in the images. So we want something that can better represent the object, right? So that is features. The features can better represent the object from the imagery, right? For example, you see a cat in imagery, and I want to capture the key features from the imagery so that I can have kind of algorithm can better understand the object from imagery, and then we can make a better decision. Right. So feature extraction involves many different the algorithm or steps, right, including spatial-based, spectral-based, statistical-based, also phase-based features. So I have done some work on this domain. Actually, there's many research going on in this direction because if you use different mathematical model, always it turns out you have different algorithm and the performance also different. Okay. All right, so we have good features. The next step is you send these features to the machine learning algorithm to do classification or regression analysis, right? In the classification stage, what we do actually is we take the features and then identify what target it is. It basically define or estimate the category of the target. Right. In the regression, basically we want to predict specific value. Right. For example, like stock market, we want to estimate the value, what's going to happen tomorrow or the day after tomorrow, something like that. We want to actually produce some specific value in the regression stage. Okay, that's a classification regression, right? And based on the prediction result, and you can do some decision making, right? Here I'm showing some kind of example, including like face recognition, right? We can extract features of face, and then we try to determine who is that person in that imagery. Also, we can do object tracking, right? This is like airborne imagery where we can actually track specific cars or the pedestrian, walking on the street. So we can also track a specific target. And robotic vision, right? So we can actually, using computer vision algorithm, also machine learning, can automate the robot as action. Okay, this whole actually theme, that includes sensing, processing, automatic decision making. Okay, that's actually all of my research theme so far. So as I mentioned earlier, the machine learning computer vision, that's my PhD work. Even after that, I've been focused on this area. So for those who have no idea of the ML or machine learning and computer vision, just give you a quick update on here. So machine learning, basically we want to focus on the applications that learn from experience and improve their decision making, right? You feed a lot of data to the algorithm, right? And through the experience, they can improve itself, improve the prediction accuracy, basically. Okay. And in the computer vision, we want to develop algorithm that can enable computer to see and understand the context of the images or videos, right? For example, here we have autonomous car, right? So we have sensor to capture this scene, and we're gonna have some kind of software can automatically detect the car, right, and also label them. And if there's any other object including this image, such as a person, this software should also automatically detect the person, also recognize it. Right? And here we have, as you can see, we have different object has been correctly or incorrectly identified here. Okay, so that involves computer vision algorithm, also the machine learning algorithm. Besides that, if you have smartphone, we have like speech recognition system, right? Where you speak to the smartphone, it can recognize the voice and do some specific actions. Also, we have security, defense area where we use machine learning, to detect kind of cyber attacks, right? And the translation, you're going to translate the from one language to another language, right? And also we have precision agriculture, right? I have done some lot of work actually on precision agriculture area. Like I mentioned earlier, captures the images. That images can be from airborne, UV, or satellite, right? And we utilize those imagery to improve the yield, right, in specific crops or other different parameters that we can predict. Okay, so recently I've been actually focused on several areas. So I'm just making a blog section here. So including image enhancement, right? And here what happens is we have collect a lot of the UV images, and we are able to develop this kind of automated system can automatically capture that images and do further analysis as pre-processing stage. We want to enhance the illumination of the images. Also, we are trying to remove the noise from imagery, increase spatial resolution, and so on, so that you can have good end product for the first process. Also, I've been focused on the data fusion, machine learning algorithms, right? Thanks for the advances in the sensors development recent years. We have a lot of sensors on the market that we can purchase, right? And what happens is different sensors provide different information, right? And how we're going to actually utilize those different information for the better decision making. So that's actually the research question, right? So how are you going to combine them, right? So we've been using different spectral imager, right? Such as the multispectral imagery, hyperspectral imagery, thermal imagery, and so on. And we try to analyze signal from those different sensors and try to combine them for better decision making. Here I'm showing one example of urban tree species detection from satellite imagery. As you can see, the colored portion in here, they are different tree types, right? So we use different color to indicate different tree types. From this imagery, for human, actually really hard to identify tree types, right? But we can use advanced machine learning algorithm, right? That can actually automatically detect the object, also recognize what type of tree it is. So this is one of the area I had done some. And recently also I've been focused on the AI in healthcare area. I found that there are a lot of potential, right, of the AI in healthcare. And here I'm showing the retina from the segmentation, right? Many cases we have this type of imagery, right? And we want to actually segment or plot the retinal fungus from this imagery. For the human, it could be really challenging, right? But if we can develop some kind of advanced AI tool that can do this job very efficiently. Lastly, as my core AI is on the machine learning computer vision, I've been developing actually different techniques, algorithms from the scratch and apply them to different domains, right? Such as face recognition, digital recognition, person identification. Also, we had tree detection, right, and many other different applications, right? That's my lab work right now going on. So we develop the algorithms and we try to apply them to the different domains. With that, I'm going to end my talk, and then I'm happy to take your question.
Thank you. So we are a small enough group so that if you have questions, just go ahead and unmute yourself and ask your question, please.
I have a question.
Sure.
For the students who are watching, do you have any suggestions for them to get into learning AI, like an online course or like a language or something?
Sure. Yes. Good question, actually. Yes. Thanks for that. The machine learning is kind of a multidisciplinary, I would say, because that involves, definitely you should know how to program, right? Computer programming languages are really important. Right now, I would suggest the Python programming is, it's really popular and it's open source, right? There are a lot of libraries, machine learning libraries that you can use for machine learning applications. And of course, there is a C++, also the MATLAB language that you can use for that. Okay, that's for the languages. And if you really want to dig into the machine learning algorithm development, then I would say take kind of fundamental machine learning course, either in the Michigan Tech or maybe we find other course online. Also, the mathematics also important, right? Many of cases we want to develop some algorithms, we start from scratch, right? So the math is really behind these algorithms, right? Once you have good mathematical background, so that you can actually develop the equations and implement this equation using the programming languages and apply them to the real life application suggestion. Also try to read the papers, recent papers, and try to implement those algorithms right by yourself without looking at their, the source code, I would say, right? By implement by yourself, you can really learn that algorithm. That's actually my strongest suggestion.
So, 10 years ago, I don't know that I've ever heard of AI before, and now it seems to be everywhere. So why is that? Is it the speed of the computers or the size of the memory, or is it all of it, or what makes this kind of available for you to do? How can you do what you're doing today that you couldn't do 5 years ago?
Yeah, very good question. So I've been asked this question by others too. So I would say two components. One is this hardware development, right? We have really advanced high performance computer right now compared to 10 years ago. Such as right now we have GPU graphic processing unit, where you can do the process much faster, even tens or hundreds times faster than before, right? And secondly, I would say the algorithm advancement, machine learning algorithm advancement, over the 5-6 years, there's tremendous advancement in the algorithm development. So many software tools been available. And also thirdly, I would say open source languages, also the people that share the code, share the paper, whole thing shared online, is open source. That actually facilitates learners to learn those things better, quickly, and develop or improve those algorithms further. Right? That I would say that could be three different reasons. I would say. Like myself, when I during my PhD and I trained some machine learning models, it took me a few days. Right now, just few hours, I can get results. That differences.